Alrighty, so today what we are going to do is multiply rational expressions. And when you multiply rational expressions, you're multiplying fractions. That's all that you need to do. If necessary, factor the top and or bottom, numerator and or denominator. You can then multiply the top by the top and the bottom by the bottom. That's just like multiplying regular fractions, right? You always multiply numerators together and then over the denominators that get multiplied together. If you want, you can cross cancel, right? You can choose to cross cancel first, and then you simplify as much as you can. All right, so you're going to find each product and assume that no denominator has a value of 0. In this particular one, these are all monomials in the numerator and denominator. So I'm not going to have to factor anything, and I'm going to choose to not cross cancel. I'm just going to multiply straight across the top and straight across the bottom. Across the top, 6 times 4 is 24. X times x squared is x cubed. Y times y is y squared. And there happens to be a z squared in the top. On the bottom, 5 times 3 is 15. X squared times nothing is just x squared, right? There's no x's in the second denominator. There are z's in both, and that becomes a total of z cubed, and there happens to be a y in that second denominator. So it becomes 24 x cubed y squared z squared over 15 x squared y z cubed. Well, I need to simplify stuff, and I need to understand that, I've got 24 and 15, which are both divisible by 3. If I take 24 divided by 3, it's 8. If I take 15 divided by 3, it's 5. I happen to have x's on top and bottom. There's more x's on the top by 1. I happen to have y's on the top and on the bottom. There are more y's on top by 1. And I happen to have z's on top and bottom. And there's more z's on the bottom by 1. This is your most simplified answer, 8xy over 5z. Back to the cross canceling. Remember, this is something that you can do. Actually, I'm just going to kind of show you that like 3 goes into itself once, 3 goes into 6 twice, and that would be 2 times 4 on the top, which is 8, and 5 times 1 on the bottom, which is 5. So you can cross cancel if you want. I prefer ones like this to go straight across top, straight across bottom, and then simplify. So what happens now when you start getting, oopsie, let me pause this for 1 second. Okay, sorry, a little bit out of order on my slides. So if you look at number 2, what ends up happening is you've got a couple of, really just one, the denominator of the second fraction is the only thing that is factorable. Everything else is as is. So we've got this binomial right now in the first fraction numerator, and I can't do anything with that except bring it down and put it in parentheses. So I really have x plus 6 in parentheses over 2x squared times this monomial 8x to the fourth. But remember, this is factorable by dots. And the way that I'm going to factor that is I'm going to do x plus 6 and x minus 6. Well, I noticed that if I have a pair of binomial factors, as long as one's on the top and one's on the bottom, I can cancel them out. So what's going to happen is this binomial x plus 6 and this binomial x plus 6 are going to cancel out. And now what's left over in the numerator is 8x to the fourth, and the denominator is 2x squared with an x minus 6 binomial factor. Well, these monomial factors on the outside actually can simplify. I've got this 8 and that 2 that can simplify, and I've got x4, x2, and that can simplify as well. So I need to get down to where I can't simplify any further. Well, 8 divided by 2 is just 4. 4 over 1, if that's fine if you want. I've got more x's on the top in the monomials, right? x4 on the top, x2 on the bottom. I've got more x's on the top by 2. And now I've got this binomial factor on the bottom. This is your most complete simplified answer. You cannot touch the x squared with the x minus 6 because the x squared is a part of a monomial and the x minus 6 is a package deal with the binomial. And that's going to be your final answer. If you take a look at this next one, the top left fraction can factor numerator by dots, x minus 3, x plus 3. The bottom of that fraction can factor by GCF. 3 comes on the outside of x minus 3. The top right can factor by GCF. A 6 comes out with an x minus 2 left over. And the bottom of that second fraction just stays as the binomial, but put it in parentheses. Here's where I'm looking for binomial pairs. And if as long as I've got something on top and bottom, whether it's same fraction or different fraction, it doesn't matter. It's going to cancel out. So this binomial x minus 3 and this binomial x minus 3 cancel out. This binomial x plus 3 with x plus 3 cancel out. What's left in the numerator is 6 binomial x minus 2, and what's left in the denominator is a 3. Hopefully you realize that we're not done because these two numbers can simplify. 6 over 3 does become a 2. So this final answer becomes 2 with the binomial x minus 2. You can put it over a 1 if you want. You don't need to, but that is your most simplified version. Okay, so it's 2 times x minus 2. Let's take a look at number 4. I can factor all of these. The top is dots. No, it's not. I keep saying that. The bottom is dots. The top left is I am, and that's going to be x minus 3, x plus 2. The bottom is dots, x minus 3, x plus 3. The top right is I am, x plus 3, x plus 4. So your factoring skills need to be really strong. If you don't need to write, what adds to 7 and what multiplies to 12 on the side, then don't. Just go right to the factored form. Okay, that's what's going to be holding you up. If you can't factor or you can't factor well, that's going to kind of take up some time. So we're hoping that by this point you can factor pretty darn well. X squared plus 4x plus 4 becomes x plus 2 and x plus 2. Now start looking for pairs of factors top and bottom that cancel. Well, this binomial x minus 3 cancels out. The x plus 3's top and bottom cancel out. I can cancel out the x plus 2 for an x plus 2. I can't get rid of both bottom x plus 2's because I can only cancel out 1 for 1. That's all that's left that I can do. So the final answer becomes the binomial up top, x plus 4, over the binomial on the bottom, x plus 2. You're better off keeping it in parentheses because you can't cancel out the x's. It's not a monomial, it's part of a package. Package deals cannot be touched unless it's an entire, complete, same package. So x plus 4 over x plus 2 is as is, final answer. Now we've got 3 different rational expressions here. So we're going to factor everywhere we can. The first fraction, the numerator is as is. The denominator is dots, x plus 5, x minus 5. Second fraction, numerator is GCF, x plus 5. Denominator is also GCF, 2, x minus 2. Third fraction, numerator is I am, x plus 5, x minus 2, and third fraction denominator is as is, just 3x to the 4th. Things to cancel out right now. I've got this x minus 2, that x minus 2. I've got this x plus 5, this x plus 5. It doesn't matter if you cancel out the x plus 5 in the middle fraction. Nothing else in terms of binomials can factor out or can cancel out. So my numerator becomes, now here's where I need to kind of make sure that I combine everything. This numerator right now, this is a monomial, this is a monomial. When I actually put those together by multiplication, I'm going to get 9x squared on the top with x plus 5. On the bottom, I'm going to see what I have in terms of monomials, and I happen to have this and this. So this is going to be 2 times 3, or 6x to the 4th, with an x minus 5. Not quite done because the 9 and the 6 can both simplify. They both can be divisible by 3. So 3 goes into 9 3 times. 3 goes into 6 twice. The monomial variables, right? I've got this whole thing right here with the x's. There are more x's on the bottom. Whoopsie. There are more x's on the bottom by 2. So I get x squared on the bottom. And now this package up top stays as is. This package on the bottom stays as is. And here's your final answer. It's 3 times the quantity x plus 5 over 2x squared times the quantity x minus 5. All right, so that should be enough to get you through your homework. Good luck. Good luck.